So what is the derivative of root x? It is 1 divided by 2 root x. We know that derivative of cos is minus sign, but we have x cube as one more function. So let us apply the chain rule. So when we have e to the power log, since the functions are inverse to each other, we can directly write y is equal to cot x. So when you have the power also variable, then we'll use the logarithmic differentiation. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today in this session, we are going to revise the chapter Differential Calculus. So from this chapter, we are discussing on 1 and 2 mark questions in this session. So let's see the distribution of marks from this chapter. So from the chapter Differential Calculus, you can expect 1 mark, 1 2 mark, 1 3 mark and 1 5 mark question. So in an average of 11 marks from this chapter. So today in this session, let's see the type of questions in 1 and 2 mark questions. Find dy by dx if root x plus root y is equal to 3. So this is an implicit function. Let us derive it. So what is the derivative of root x? It is 1 divided by 2 root x. And what is the derivative of root y? That can be written as 1 divided by 2 root y with dy by dx. When you are differentiating y with respect to x, you need to derive the function and write dy by dx along with the derivative of y. Now 3 is there, it's a constant 0. So now I'll shift this to the right hand side. I'll get 1 by 2 root y dy by dx is equal to minus 1 by 2 root x. We can see that 2 get cancels and I can write dy by dx as square root of y by x. So we have minus outside the square. So this is the answer. If y is equal to cos x cube, find dy by dx. We know that derivative of cos is minus sign, but we have x cube as one more function. So let us apply the chain rule. So now dy by dx is equal to, so derivative of cos function is minus sign, so it will become minus sin x cube, and derivative of x cube is 3x square. So therefore we can write this as 3x square into sin x cube. Next, if y square is equal to 4ax, find dy by dx. So on the left hand side we have y square. So the derivative of y square can be written as 2y, and along with that we can write dy by dx. So 2y into dy by dx. 4a is constant, derivative of x is 1. So we can cancel 2 1s are, 2 2s are, or dy by dx can be written as 2a divided by y. Next, we have y is equal to e power x, x power e, e power e. The derivative of exponential function is e power x only, and derivative of x to the power e can be written as e into x to the power e minus 1. E power e is a constant term, so its derivative is 0. So therefore, e power x plus e x to the power e minus 1. Next, differentiate 5 e power x minus log x minus 3 root x with respect to x. Now let's take y is equal to 5 e power x minus log x minus 3 root x. So therefore dy by dx is 5 e power x, because exponential function derivative is itself. Now log x can be taken as 1 by x minus 3. Derivative of root x can be written as 1 by 2 root x. So we can write like this. Next, y is equal to e power log cot x. So when we have e to the power log, since the functions are inverse to each other, we can directly write y is equal to cot x. Now derivative of cot x, that is dy by dx, is minus cosecant square x. Next, 2 marks question. We have y is equal to square root of x plus square root of x plus square root of x until the infinite terms. So then prove that dy by dx is equal to 1 divided by 2y minus 1. So we know that y is square root of x plus square root of x plus until infinity. So I'll replace the whole sum of this into y. That I'll write y is equal to square root of x plus y, because this is what y means. So now here, squaring on both sides, we will get y square is equal to x plus y. Let us derive it. This is 2y dy by dx is equal to 1 plus dy by dx. So when you take dy by dx as a common factor from these two terms, you will get it as 2y minus 1. So here you have 1. So therefore dy by dx can be written as 1 divided by 2y minus 1. Next, if y is equal to x power x, find dy by dx. So when you have the power also variable, then we'll use the logarithmic differentiation. So let us apply log on both sides. Then we'll get log y is equal to x into log x. Because we know that log m to the power n can be written as n log m. Now let us derive it. Log y can be taken as 1 by y dy by dx. Here let us apply the product rule. So first function into derivative of log x, that is 1 by x, plus second function is log x, derivative of x is 1. X and x get cancels. So here you have dy by dx. Let me shift y here, then it is y into 1 plus log x. So we can replace y as x power x 1 plus log x. So this is the derivative of the function. Next, y is equal to log of 1 minus cos x divided by 1 plus cos x. Prove that dy by dx is equal to 2 cosecant x. So from the multiple angle formula, so we can write 1 minus cos x as 2 sin square x by 2 and 1 plus cos x as 2 cos square x by 2. So here I'll write y is equal to log of, so 1 minus cos x can be written as 2 sin square x by 2 whole divided by, and this can be written as 2 cos square x by 2. So 2 get cancels. Here y becomes log of tan square x by 2. Now we have a series of functions here. So let us apply the chain rule here. Now dy by dx is equal to log of any function is written in the form of 1 divided by the function. So here we will take 1 divided by tan square x by 2. Now what is the derivative of tan square x by 2? That is 2 tan x by 2. Again let us derive tan x by 2. It is secant square x by 2. Again let us derive x by 2. It is 1 by 2. So now here 2 get cancelled. 1 tan function get cancels. Next we have dy by dx is equal to, so here we have 1 divided by tan x by 2. So that can be written as cos x by 2 divided by sin x by 2 into secant square x by 2 can be written as 1 divided by cos square x by 2. So cos x by 2 cancels here. So here we have 1 divided by sin x by 2 cos x by 2. 1 divided by sin x by 2 cos x by 2. Now this can be written as sin x, because in half multiple angle formula we have sin x as 2 sin x by 2 cos x by 2. So here we don't have 2, let me shift here, then it will become sin x by 2. So this can be written as 1 divided by sin x divided by 2, or which can be written as 2 by sin x And what is 1 by sin x? Cosecant x. So we can write this as 2 cosecant x. So dy by dx is 2 cosecant x. So use the formulas of half angle formula, then derive it. Next, find dy by dx if x power y is equal to y power x. Again, we have variables on the exponential. So let us use logarithmic differentiation. Applying log on both sides, we will get y log x is equal to x log y. So both sides we are going to use the product rule. So first function derivative of second plus second function derivative of the first. Next here, first function derivative of the second plus second function derivative of the first. Now let us take dy by dx as common factor. So dy by dx is log x minus x by y we will get. So I'll shift this, then here we have log y minus y by x. So we get dy by dx is equal to, so here we get y log x minus x divided by y, and here we get x log y minus y divided by x. So on cross multiplication we get dy by dx is equal to y into x log y minus y whole divided by x into y log x minus x. So this is the derivative of the given function. Next we have, if sin y is equal to x sin a plus y, prove that dy by dx is equal to sin square a plus y divided by sin a. So now here we have sin y is equal to x into sin a plus y. Let me take x is equal to sin y divided by sin a plus y. Now let us differentiate. We will apply the quotient rule for the right hand side. Derivative of x is 1. Now here we will use the quotient rule, that is in the form of v u dash minus u v dash divided by v square. So u dash and v dash represents the derivative of the first and second function. So u we will take it as sin y and v we will take it as sin a plus y. So here sin a plus y, derivative of sin y is cos y into dy by dx. Minus next we have sin y, derivative of sin a plus y is cos a plus y into dy by dx whole divided by sin square a plus y. Now if I take dy by dx as a common factor here, the numerator will be in the form of sin a cos b minus cos a sin b, which can be written as sin of a minus b. So therefore here I will get sin of a minus b whole divided by sin square a plus y. So y and minus y get cancelled. Keeping dy by dx here and cross multiply, we will get dy by dx is equal to sin square a plus y divided by sin a. Next we have y is equal to x to the power sin x, find dy by dx. So let us apply the log on both sides. We will get log y sin x into log x. So here derivative of log y is 1 by y dy by dx, and sin x log x, let us apply the product rule. Sin x into 1 by x plus log x into cos x. So dy by dx is equal to y into sin x divided by x plus log x into cos x. So we can replace y as x power sin x. So this is the derivative of the given function. Next we have If y is equal to a square minus x square to the power 10, find dy by dx. So when we have any function to the power n, we will write it in the form of n into x to the power n minus 1. So therefore, here dy by dx can be written as 10 into a square minus x square whole power 9. Next we have the function here, derivative of a square will be 0 minus derivative of x square is 2x. So therefore the answer is minus 20x into a square minus x square whole to the power 9. So this is how we are going to derive the given function. We will meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.